Alright, hey guys, this is Thursday, April 16th for Algebra 1. And so today what we're going to do is we're going to do probabilities of multiple events. And so remember, the probability of an event, you just take the number that you're looking at, the outcome that you're looking at. So how many, if we're doing blue marbles, then you put the number of blue marbles on top, and then you put the total number of marbles on the bottom. That's how you set up your fraction. Now, we have a couple definitions here. You have independent events. Events that do not affect each other's probability of occurring are called independent events. And so what happens now, whereas yesterday I did what's the probability of this or that happening, today we're going to do the probability of this and that occurring. And so for an or, if it's an or, basically the rule is you add. If it's an and, the rule is you multiply. And so it says, so like up here I have 3 green, 2 red, and 1 blue. And so for two independent events, then if I want to know the probability of P and B, then you just do the probability of A times the probability of B. And so you just do the first, set up the first fraction, reduce it, and then set up the second fraction, reduce it, and then multiply them together. And so if we stuck with this problem over here with two independent events, remember an independent event is, again, the definition, is events that do not affect each other's probability. So if I did the probability of choosing a red marble and a blue marble. So the probability of choosing a red and blue. So if I choose a red marble and then I put it back and I choose the blue marble, then that's not going to affect the probability of either. So those are going to be independent events. And so if I did this, then I would do the probability of A, which is the red. So that would be 2 over, and then there are 3, 5, 6 of them total. So it'd be 2 over 6 would be the probability of choosing a red. There's 2 red over 6 total, times the probability of choosing a blue. So the blue is 1. So there's 1 blue, and there's 6 total. And so it'd be 1 over 6. And so all we're going to do at that point then is multiply the two fractions together. And so when you multiply the numerators together and the denominators. So when I multiply this, it'd be 2 times 1 equals 2. And then 6 times 6 equals 36. So I get 2 over 36. And then I could reduce that to 1 over, what would that be? Half of 36 is 15, 16, 17, 18. So 1 over 18. So 1 over 18 is my probability. So again, two independent events that don't mess with each other. The probability of me choosing a red one and then put it back, and then the probability of choosing a blue one next, then the probability is going to be 1 out of 18. And so the two events do not affect each other, so you just do the probability of one, probability of the other, and multiply them together. And so those are for two independent events. Now, if you look at this next definition is dependent, which means choosing one depends on the other. And so these are two events without replacement. And so basically the key here is that if I wanted to do an independent event with the marbles, I had to put the marble back, because then that didn't change the outcome for the next one. But what happens if I chose a red one and a blue one here? Probability of red and blue. But in this case, what happens is I'm going to actually put up the marble back, or keep the marble, I mean. So these are two events without replacement, meaning I'm going to choose a marble, and then I'm going to keep that marble, and then I'm going to choose another marble. And so what's the probability of choosing a red and blue marble this time? Well, to do it, what you have to do is you have to do the probability of A. So it starts out the same. You still do the probability of A. And then you're going to multiply by the probability of B given A. And so in statistics, when they give it to you like this with this line cutting down through it, that just reads given. And so it's called a conditional probability, and that's the probability of event B occurring after event A, and so that is read as the probability of event B given that event A has already occurred, so B given A. So this reads B given A. And so what that means is what's the probability of event B occurring given that A has already occurred. And so what you do here is you're still going to do the probability of the red. So the probability of the red is 2 over 6. So that's the probability of the red. Now, I took that red marble out and I did not put it back. I kept it. And so that's going to change the probability for the blue. And so to do the probability of B given A, I have to find the probability of blues given I took a marble out. And so what happens is the blue stays the same. It's still the total number of blues. So it's 1 blue. But now instead of having 6 marbles that I chose out of, I only have 5 marbles because I already picked one out and kept it. And so it's just times 1 over 5. So 2 times 1 then is 2. And then 6 times 5 is 30. And so that reduces to 1 over 15. So notice the difference in the two problems. One problem I did as independent, meaning they didn't affect each other. I picked the marble up, put it back, didn't affect it. And so that is where you just take the probability of one and you multiply it times the probability of the other. Now, two events without replacement dependent, then that means the second choice depends on what the first choice was. And so, and it means the order matters, and it means that you didn't, get your, what am I trying to say? You didn't put it back. And so you take the probability of the red, which is 2 over 6, and then you take the probability of the blue, which is now 1 over 5, because I kept one marble out, and so you get 1 over 15. And so notice the difference in the probabilities. We did the probability of me choosing a red one and then a blue one here, and got 1 over 18 when we didn't put it back, or when we did put it back. And then over here, probability of a red one and the blue one when I didn't put it back and kept it was 1 over 15. And so that's important. And we'll kind of continue on from there. So if you look, that's pretty much how things are going to go with it. They give you a few more examples in the book that you may want to look at. But that's essentially how it's going to work. Now, you need to keep in mind your definition is important. What's the difference between independent and a dependent one where you're without replacing it? So just make sure I hit everything. So I think you should be okay to do the homework from that. So homework is going to be on page 401, and it's 1 through 10. Now, just to kind of hit it real quick, number 1 says a red ball is removed and replaced before a green ball is removed. And so you're going to do the red ball and then the green ball. So the order matters. You have to make sure it's A and then B. So make sure you set it up right first. That's going to change how you do this. So number 1, number 2, the white ball is removed and replaced before a green ball is removed. Do the probability. So you should be able to do that. So notice the key difference there is when it says is removed and replaced, or is removed and not replaced. Those are going to be the key differences. So if you replace it, that's going to be this right here. If you do not replace it, then that is going to be these top right here. And so you just make sure you understand which one you're doing which on. But you should be okay there. And so that'll be today's lesson. If you have any questions, get up with me. Again, your homework is on page 401, 1 through 10.